Hi guys, welcome back to my channel. Today I want to do a challenging question about buoyant force. Okay, the question reads, an aqua runner with 80 kilogram mass and 1 gram per centimeter cube density has 70% of his or her body outside of water. What is the apparent weight of the runner? And then here are 4 answer choices for you. You can pause the video and try it on your own. Okay, we're gonna dig into this. So basically, this question gives me 3 pieces of information, right? The aqua runner who runs in water or whatever fluids has a 80 kilogram mass, okay? And then the density, the body density of the runner is 1 gram per centimeter cubed. And then 70% of his or her body is outside of the water, meaning that 30% is inside the water, is submerged in water, right? What is the apparent weight of the runner? Okay, so usually do the physics problem, you would draw a picture. Okay, say this is the environment of where the runner is running, and then 70% of the body is outside of the water. This guy weighs 80 kilogram. And then the density of this person is 1 gram per centimeter cubed. Okay, so that's it. And then what is the apparent weight of the runner? Okay, all right, so this is a really challenging problem that you need a lot of background knowledge to solve this. Okay, and then this is not the problem that we usually see in our physics classes in undergraduate. Okay, so it is really challenging, but let's break it down, okay? So let's first set straight what is apparent weight, okay? So let me draw another picture, just a general scenario for you. Let's say I have an object that's 100% submerged in the water, right? And then if I were to draw a free body diagram, everyone knows that there's mg, right? The weight of the object. And then because it's submerged in water, so this, or fluids, right? Any fluids can provide a force called buoyant force. So buoyant force is towarding the other direction, right? So this is a BF. And then buoyant force. If you have watched the other fluid video, the equation is rho times V times G, right? And then this rho is the density of the fluid. If it was water, then the density would be what? 1 gram per centimeter cubed. That's the density of water, right? If the fluid was water. And then the V is really how much of the water has been displaced due to the submersion of the object, right? If 100% of this object, the volume of this object is submerged in water, then you know that the volume of the water that's been displaced equals to the volume of this object, right? 100% volume of this object. Okay, so that's the volume. And then G is just 10, right? Okay, so that's buoyant force. But are we missing any other forces on our free body diagram, right? Okay, so when we did all these early on in our physics learning journey, that we know that there's a force called normal force, right? And then normal force is really also pointing the opposite direction as the weight mg, right? So in this case, there's also a normal force that's going upward, okay, exerted by the water. And then on MCAT, you can assume apparent weight is equivalent to normal force, okay? All right, so from the 3 forces that I see on my free body diagram, if this thing is stationary, then we know the net force is 0, right? So the downward force really cancels out the upward forces, right? In other words, I mean mg equals the buoyant force plus AW, right? Plus the apparent weight, okay? So this is the equation that you never learned in any of your physics classes, I bet, but it's super highly yield on MCAT if they want to test you on fluids, okay? All right, so now let me break down this equation more for you, okay? So mg basically, the mass of the object is basically what? It's basically the density of the object times the volume of the object. That gives me mass, right? Okay, equals to, and then we said the buoyant force is the density of the fluid times the volume of the water that's been displaced times G equals plus AW, okay? All right, so then if I say this object's density is 1 gram per centimeter cubed, right? That will be the same density as water, as my water here, right? So basically this thing equals to this if they have the same density. And then if it's a fully submerged, then we know this V equals this V, right? And then this G equals this G. Then for this equation to establish, my apparent weight has to be what? Has to be 0, right? The apparent weight has to be 0 for this equation to equal, right? So this tells us what? This tells us if this thing has the same density as the fluid that it's submerged in, and if also it's 100% submerged, so that the apparent weight will be 0, okay? But now let's look at a different scenario, the scenario of our question that we have a person. And then this person, 70% of the body is outside of the water, right? So 70% of the person's volume is outside of water. And then this part of the body is inside the water. So that's 30% of the person's volume is inside, is submerged in the water, okay? So how much is the volume of the water that's displaced? It's 30% of V, right? Okay, so let's copy and paste our equation, okay? So our equation is rho times V times G equals this, rho times V times G plus 8W, okay? So basically, my question, this apparent weight, is this apparent weight that I'm solving, right? Okay, so what about the person's density? We know it's 1, right? 1 gram per centimeter cubed, right? And then V of the person, I don't know it's a volume. I'll just put V and then times G, okay? And then the water's density is also 1G cm cubed, right? And then what about the volume of displaced water? We said it's 30% of V, right? And then times G and then plus 8W, okay? All right, so you can see that this part of the equation is 100% of the person's what? Weight, right? Whereas this part is really what? 30% of the person's weight. Okay, do you see the math here? That tells me what? That tells me my apparent weight has to be 70% of the person's weight, right? You have to have 70% so that the equation, so that this equation can be established, right? Okay, so what is 70% of the person's weight? It's simply 70% times 80 kilogram times 10, right? That gives me 70% times 800 Newton, and then that's 560 Newton, right? My answer will be B, okay? I hope that's helpful, and I hope you got the right answer. So next time on MCAT, you can just really quickly solve this problem, right? If you know the density of the person is the same as the fluid's density, and then you just have to pay attention. It's 70% of the body that's outside of the water, right? So then it's 70% times the weight, okay? So if it's 30% of the water that's outside of the water, then the math will be 30% times weight, okay? And then sometimes they don't tell you how many percent is outside of the water. They tell you like 50% is submerged in the water. Then you know, it's just different wording, but the same idea, same logic. Then it will be half of the weight, which is the apparent weight, okay? I hope that's helpful.